Newton's first law states that an object at rest will remain at rest, and an object in motion will remain in motion unless acted upon by an outside force. To prove this, we'll be stacking 3 cups and putting a card in between them, which will stop the cups from falling into each other. When the cards are removed from underneath each cup, gravity will act on the 2 cups on top and they will fall. We did this experiment again with different cups in different positions.
In order to demonstrate Newton's second law, F equals ma, we will use a cart and a hanging mass to calculate the variables in the equation. We will add masses to the string to show how force is directly related to the mass. First, we will weigh the cart on a triple beam balance. After that, we will connect the string to the cart and hang it over a pulley system over the edge of the table. Then, we will attach a mass to the end of the string that will exert a force on the cart, pulling it across the track. We will then use a stopwatch to time how long it takes the cart to move from one side to the other.
We then use the equation force equals mass times acceleration to solve for the cart's acceleration. We did the same thing with the 20-gram mass instead of a 10-gram mass. And we use the same equation to solve for this cart's acceleration. And we did it again with the 30-gram mass. We again use Newton's equation to solve for the cart's acceleration. Through this experiment, we can see how the force has a direct relationship with the acceleration and the mass, and how the acceleration has an inverse relationship to the mass. Newton's third law states that for every action there is an equal and opposite reaction. When I place the 10-gram mass on the card, nothing happens because the card pushes back up with an equal but opposite force. The same thing happens for the 20-gram mass. And for the 30-gram mass too. But when I place the 50-gram mass on the card, the force downward becomes greater than the force the card can push upwards, so it falls. When I hit and kick the water bottle, the force I exert on the bottle is greater than the force the bottle exerts on me, so it is knocked off the table.